There's this quiet revolution happening literally right under your feet when you're in an EV. We're talking about the very heart of the car, the battery pack. And right now, engineers are in this massive race to completely redesign it from the inside out. So today, we're going to see exactly how they're pulling it off.
All right, so here's the game plan. First, we're going to dig into the big problem that every EV driver knows all too well. Then, we'll look at two major breakthroughs engineers are using to fix it. One is about how they build the batteries, and the other is a massive electrical upgrade. After that, we'll see what new problems pop up because of these fixes, and, of course, how they're being solved. And finally, we'll look at what all this means for the future.
So, let's be real. Have you ever wondered about this? You pull up to a fast charger, right? And the EV in the stall next to you is fully charged and gone in the time it takes you to grab a coffee. Meanwhile, you're still sitting there watching the percentage slowly tick up. Well, the answer to why that happens, that's the key to understanding all of this innovation.
Yeah, that huge gap in charging time, it really all boils down to one single thing. This constant battle that car companies are fighting to give us, the drivers, what we want. It's what we can call the EV driver's dilemma.
Look, we all want the same three things, don't we? We want more range, we want to charge way faster, and we want amazing performance. But getting all three of those at the same time, that's the giant puzzle. And it's exactly what's forcing engineers to to tear up the old rulebook and completely rethink how a battery is even built. Okay, so to solve this big dilemma, engineers are basically coming at it from two different angles. The first one isn't about fancy new battery chemistry. Nope, it's something way more fundamental, the architecture. They're figuring out how to build a better battery by physically redesigning the pack itself to be, smarter and way more efficient. And I absolutely love this analogy. Think about it like this. An old-school battery pack? It was kind of like a house with way too many walls and little hallways breaking everything up. Those walls were the modules. The new way of doing things is like an open concept home. You just knock down all those walls and boom, all of a sudden you've got so much more usable space and everything just works better.
So this whole open concept idea actually has a name. It's called cell-to-pack, or CTP for short. And what it does is it gets rid of that middle step completely. So instead of putting battery cells into modules and then putting those modules into a pack, CTP just puts the cells right into the main battery case. Simple as that.
And the impact of this one change is just massive. I mean, by ditching those bulky modules, these cell-to-pack designs free up as much as 50% more usable space. And they cut the number of parts by almost half. At the end of the day, that means a huge jump in energy density, which for you and me translates directly into more range. Now, cell-to-pack is a really big deal for sure, but it's not the end of the line. The next step in this evolution is called cell-to-chassis, or CTC. So with CTP, the battery is still kind of a separate box that you put in the car. But with CTC, oh man, the battery cells are built directly into the car's frame. The battery literally becomes part of the car's structure.
Okay, so that's the big structural change. But remember I said there were two angles? Well, the second major breakthrough is all about the electricity. Engineers are doubling the voltage of the entire system, and that single move is a total game changer for charging speed and efficiency.
Here's probably the easiest way to wrap your head around this. Just think of electricity as water flowing through a hose. The current, that's how wide the hose is. And the voltage, that's the water pressure. Now, if you want to get more water out, you could grab a giant, heavy fire hose. That's like having a high current. Or you could just crank up the pressure and get the same amount of water through a much smaller, lighter hose. And that's high voltage. And this is why it's such a massive deal. By jumping from the old standard of 400 volts up to 800, you can shove the same amount of power through the system with half the current. This is the secret sauce for ultra-fast charging. But it gets better. It also means you can use smaller, lighter, and cheaper copper cables throughout the car. That saves weight, which improves efficiency, and can even make the car handle better. But using less current isn't just about the size of the wires. It's about waste. When you push a ton of current through a 400-volt system, you generate a crazy amount of heat. And that heat, it's literally just wasted energy. Plus, it creates this huge problem of how to keep everything cool. An 800-volt system, because it needs less current, just slashes that problem way, way down. So we've got these super dense battery packs and crazy high voltages. Everything sounds perfect, right? Well, not quite. Turns out, these powerful new designs create a whole new list of engineering headaches that have to be solved. And this quote really captures the biggest drawback of that cell-to-pack design. See, when you glue all those cells together to save space, you'll lose the ability to fix them one by one. So if one little cell goes bad, you might have to replace the entire, and I mean very expensive battery pack. And yeah, that maintenance problem is just one piece of the puzzle. These new designs bring on a whole bunch of other challenges. You've got intense heat that has to go somewhere, new kinds of stress on the car's structure, and of course, brand new safety risks that have to be taken care of. Let's just zero in on that first one, heat. Think about it. You're packing more power into a smaller space and then charging it at ridiculous speeds. What do you get? A lot of heat. And without those old modules to help spread it out, you now need some seriously sophisticated cooling systems to deal with it.
And this is where the engineers have gotten super creative. You know, the early cooling systems were pretty simple, just some plates with coolant running through them. But that wasn't good enough, so they evolved into these complex, snake-like channels for better cooling. And now, the really cutting-edge stuff is these micro-channel plates that have tiny little fins inside to suck the heat away with incredible efficiency.
Okay, but what about protecting against a total disaster, like a short circuit? Well, the solution is pretty wild. It actually comes from the world of airbags. Companies have developed something called pyro fuses. These are basically tiny explosive switches that can completely cut the power in a few milliseconds if something goes wrong. It literally stops a fire before it even has a chance to start.
So where is all this tech actually going? Let's take a look at how these trends are shaping the future of the EV itself. You can really see the whole journey laid out pretty clearly. We started with that complicated cell to module to pack design. Right now, we're in the middle of the cell to pack era, which makes things way simpler. But the end game, the clear destination, is cell to chassis, where the line between the battery and the car just disappears.
So, here's the biggest takeaway from all of this. The battery is having a total identity crisis, in a good way. It's not just a dumb fuel tank anymore. It's evolving from being this passive box that holds energy into an active, structural part of the car. It is literally becoming the car's skeleton. And that massive shift leads us to a really fascinating and maybe a little provocative final question for the whole auto industry. You know, as the battery becomes the actual skeleton of the car, who's really in charge? Who's in the driver's seat? Is it the car company that designs the vehicle, or is it the battery maker that designs its very bones?